So let's imagine that we're Archimedes, and our king asks us to determine whether or not a crown that was given to him as a gift is pure gold. So how exactly would we go about in solving this problem? How can we use Archimedes' principle to determine the answer, the solution to our problem? Is the crown real gold? Well, one way that we can answer this question is by comparing the specific gravity value of that crown that was given to the king to the specific gravity value of pure gold that can be obtained from experimental results. So we know that the value of specific gravity of gold is 19.3. So if the specific gravity value of that crown is also 19.3, that means the crown must be pure gold. But if the specific gravity is some other value, that means our crown is not pure gold. Why is it that we can use specific gravity? Well, recall that specific gravity is simply the ratio of the density of the object to the density of water. And the density of any object is an intensive property of that object. And that means the density remains constant regardless of any change in shape, size, or form. So for example, the density of a small gold nugget is the same exact density of a gold crown. So let's begin by taking a spring scale, and let's suppose we take our crown and we weigh our crown using that spring scale. We weigh that crown on land. So this is the diagram for the crown weighed on land. Now let's suppose that weight of the object of the crown is given by the letter W. Now then we take that same spring scale and we submerge our crown into water. And we read what the weight of the object is now. So let's suppose the new weight of the object is given by W prime. So this is the actual weight of the object, and this is the apparent weight of the object when the object is weighed on in the water. So, knowing these values, knowing these readings, we can determine what the mass of each object is. So the mass of the object on land is 14.7 kilograms, and the mass of the object in the water drops down to 13.4 kilograms. Now, knowing the specific gravity of gold is 19.3, let's determine whether or not the crown is real gold. In the first step, we want to examine diagram 2, and we want to look at all the forces acting on our gold crown or our crown inside the water. So what are the forces acting on the crown inside the water? Well, we have the force of gravity, which is pulling downward. We have the buoyant force created by the fluid pressure, which is pointing upward. And we have the tension in our rope, which is connecting the scale and the crown. So, we have two forces pointing up, one force pointing down. We want to solve for the force tension. So because the object, the crown, is in static equilibrium, the sum of all the forces acting on the object along the y-axis must be 0. So using that result, we can calculate the following equation. So the force tension is equal to the force of gravity minus the buoyant force. Now, the force of gravity is simply W. It's the actual weight of the object. So let's replace force of gravity with W. And the tension in our rope is simply the weight that is read by the scale when the object is submerged into our fluid. So we can replace force tension with W prime. So W prime equals W minus force of buoyancy. And we can solve for the force of buoyancy. And we get the following equation, and let's call this equation 1. So W minus W prime, our actual weight minus the apparent weight, is equal to the buoyant force. Now recall that the force of an object is equal to mass times the gravitational constant g. And we know from Archimedes' principle that the buoyancy force is equal to the mass of the liquid that takes up the same volume as the object that is submerged into that liquid multiplied by the gravitational constant g. And recall that mass of a liquid is equal to the density of that liquid multiplied by the volume that liquid takes up. So, we get that force of buoyancy is equal to mass of the liquid multiplied by g. Mass of the liquid becomes the density of the liquid, in our case it's water, so H2O, multiplied by the volume of the object multiplied by g. And recall that the weight, the actual weight of our object is simply the mass of that object, m, multiplied by g. And once again, we can replace mass of that object with density of the object and the volume of that object. So we get density of the object multiplied by the volume multiplied by g. So let's call this equation equation 2 and this equation 3. So we take equation 3 and we divide equation 3 by equation 1. So we get the following result. Our actual weight of the object W divided by the difference between the actual weight and the apparent weight W divided by W minus W prime is equal to, so W is equal to M times G, so M times G, and W minus W prime is equal to F times B, shown here. So now we replace M times G with this quantity, the density of the object divided by volume of the object divided by our gravitational constant g, and FB is equal to the density of the liquid multiplied by the volume that the object takes up, so these V's are the same, multiplied by the gravitational constant g. So the V's and the G's appear on both sides, top and bottom, so we cross those out, and we see that this ratio, the ratio of the actual weight of the object to the difference between the actual weight and the apparent weight, is equal to the ratio of the density of the object divided by the density of the liquid. And the density of the object over the density of the liquid is simply the specific gravity of that object. So specific gravity of that object is equal to this ratio. The ratio we're looking for to begin with is equal to, well, we have this divided by this, and W is simply M times G, W is M times G, and W prime is M prime times G, where M prime is the apparent mass of the object, and M is the actual mass of that object. So notice G's appear on each term, so the G's cancel out, and we're left with mass of the object, the actual mass of the object, divided by the difference between the actual mass of the object and the apparent mass of the object. So we have 14.7 kilograms divided by 14.7 kilograms minus 13.4 kilograms, and we get a ratio 11.31. Notice this is not the same value as 19.3, and that means the densities of the two objects don't match. The density of pure gold and the density of the object, the crown that was given to the king, don't actually match, and that means the crown is not pure gold. In fact, a value of 11.31 would mean that the crown is in fact lead and not gold.